So the overall theme was smart retail. So this is something that we tried to find a good solution for. So we like AI pathfinders or AI anything search. Um, it's the team name and the product name. So anything search means you can search for literally everything. And if you want to now go even into the figuratively stuff, yeah, you can even search in any kind of language characters. This was one of the gimmicks that we presented. We were focusing on bringing sentiment search to Spryker. Who is we? Guido already made a small introduction to the team. So it was Salman, Karan, Dennis, and myself. So all of us are primarily backend developers or developers in the industry for, let's say, 10 plus years. And all of us had some experience with Spryker or at least the matter at hand. So AI enhanced searching. So what we basically tried to focus on or enable was bringing semantic search and the user intent to the online shop, because all we are aware of is Google, right? I can search in Google for whatever I want. And usually Google is smart enough to give me some feedback, right? So it's not the way that you search for camera 8 megapixel, but you have sometimes some questions more or less that you quote into Google, and it comes up with some blogs, maybe even right now some product recommendations, right? I remember a talk on the Excite as well, speaking about how Google right now works and the semantics of Google searches and stuff like that. But that was not the topic. We wanted to bring all of that you already can do in the normal Google search into our Spryker e-commerce system, so into our e-commerce solution. So what we basically focused on was bringing semantic search based on vector databases into Spryker. So the goal was to improve the quality of search results by interpreting our user intent or user query from natural language into a proper context, using this then to generate not just like hard word matches like we do it by default in Spryker, but also to bring a vectorized interpretation of what the customer is looking for into it. I will go into a small figure. You can see it already on the left-hand side, how this like worked. But basically we were searching with the user query against the vector database to find the proper match of products fitting the user's description or the user's intent. We also went through the entire process of how to publish this vector database. In this case, we now used Pinecone, but this adapter is pretty interchangeable. So you could now use any kind of vector database and any kind of embedding model. We went in this case for Gemini. So we went through a publishing process of products to create an embedding vector, store this in the database, and then on runtime, so when you search for something, we took the user query, generated an embedding onto this, and then searched into searched into the vector database, and then enhanced the search that came from the result sets and used this to push stuff to Elasticsearch. The way this works is basically a approximate nearest neighbor search inside a vector database. And inside there, we're using something called the cosine similarity. It's kind of like a vector is kind of like a, not even 3-dimensional, but for us, it was like a 765-dimensional space. And a vector then gets matched about the angle that it's related to other vectors in this search. So it's very mathematic. There's a link for you if you are interested how semantic searching with vectors works in depth. But yeah, it was the baseline that we wanted to bring to Spryker. So as I already was like highlighting, there were 2 pieces of this project. So the one time was publishing time and the other time was querying time. And this even includes a typo that hasn't been fixed since our initial presentation. There we go. So on publishing, we went through the entire database and grabbed every abstract product, and we indexed it with an embedding transformation inside of our vector database. So basically, we loaded the entire Spryker database into Pinecone, which was just 120 something products, which took a few minutes to do so. But then there was a vector representation of the data. On the other hand, when we were invoking a search, so when we searched through Elasticsearch, we could then also provide data, for example, the user intent, right, to this vector search, and then we got in return a result set of SKUs. This SKU result set we then used to improve the Elasticsearch search and higher rank those products that were recommended as a proper fit. How does this look right now? It basically looks like a like that's the vector database. It's like some numeric values, and then you have like some metadata. For us, the ID was basically the SKU, so we higher rank those for our query. Locally, I unfortunately don't have it running, but I can share in a second with you some screenshots how this looked like. Yeah, this was the live demo that we did, and I can also throw into the chat how this, for example, looked like when searching in. No, I think Sam, you did a great example with. Yeah, so for example, we were in the English shop. Let me just send this to the chat, and we were showcasing a search for a German phrase, right? So I was searching for Urlaubsfotos. And we got the recommendation about a camera, which was roughly about, what was it, like 37 euros, right? So it was not a super expensive one, but it was just for vacation pictures. But we were, and you need to keep this in mind, we were in the English context. So the Elasticsearch would have returned nothing. Going through user intent and going through our vector database, we were capable of returning even products for that context. It takes an even more interesting turn when we take a look at nature photography. So this was another case that we presented, that if you search for nature photography, we were seeing already something indexed for, presented as a higher indexed product for a higher price class. So then suddenly a product for 160 euros was presented as a proper fit for nature photography. We then went through some other cases. You can already see this in the tabs on top for film cameras and stuff like this. But the greatest example of how the sentiment search can even improve your online business is by enabling any kind of searches, for example, in Urdu. So Salman gave me this search query on like, hey, maybe search for that. And you could see that even searching in Urdu, so not even in, let's say, the Latin or Arabic numbers in the Latin alphabet, we were getting results, because for our vector database, it doesn't matter what type of query you send, because we just get an embedding. So for every embedding model that you use, most of them, because they're large language models, they're multi-language compatible, even Urdu compatible. So we were able to use Gemini to transfer this words, I guess, into the vector, which was for mobile phones, right? So this is Urdu, whatever is written there, for mobile phones. Now you can ask yourself, why is there a Sony CyberShot camera? And this is simply due to the fact that this camera has in the description, it shoots like a smartphone pictures or something like that. So this was why it was higher ranked than the Sony Galaxy, apparently. But yeah, everything comes down to data quality. And this is also something when we now take a look at the next steps. So what we wanted to do basically as a next step, and I already started working on this a little bit, doing some abstractions for the vector database and the embedding services, so that we can just plug and play whatever we need, right? So you could then go away from Pinecone to Quadrant, which was our initial idea, but we then just decided for Pinecone because it's a software as a service provider. But you can also, of course, change the embedding. So go away from Gemini, go to OpenAI. Maybe you have your own private GPT, right? So maybe you have your own Azure instance, then you can switch to that one. Go into more sophisticated data preparation. Right now, we just went for name, category, product description, very high level, right? So there could be more and more data injected into generating this this vector, and of course taking care that you have proper data provided and not just Spryker demo shop data. And of course, then if you go down the rabbit hole and becomes more data, then you need to think about chunking, because certain indices just accept a certain or certain embeddings just accept a certain amount of tokens. Tokens then need to be chunked, so descriptions maybe need to be split, yada, yada, yada. So that was like something down the road that we could imagine that this module could improve, and yeah, basically is on the roadmap for that module. And that was basically what we presented already on the Spryker Excite Hackathon. And yeah, thank you all once again.
Thank you so much. When you talk about roadmap, do you envision this to be picked up at a future hackathon, or do you actually going to work on it in between? Or
yeah, so from a team point of view, I will reach out to the guys during Hack Week. I know this is on the agenda, and I will not spoiler anything further. But in Valantic terms, we already are thinking on how we can maybe even build an abstraction as a PHP package. So not even Spryker abstraction, but PHP abstraction wise. So
nice.
I'm
Definitely
trying to
will
carry
be
it on.
continued then.
Yeah, in one way or another.